Hello friends, welcome back to the next lesson on the chapter of permutation combination. And as you know, we have already completed the selections part of this chapter, and I hope you have been able to solve the assignments for the same which have been loaded up on the Coding Ninjas website. So the next thing I'm talking about now is distributions. Distribution is an important element again because there are certain standard questions on distributions. But in distributions, again, just like selections, there are two kinds of distributions. When you distribute from distributions can happen from identical objects, or distribution can happen of identical objects, or distribution can happen of distinct objects. And there is a standard set of questions both on identical objects distribution and distinct objects distribution. Let's look at those. First of all, let's understand the situation and the formulae, and then we'll go to the question in the next lesson. So if you have, let's say, n identical objects, and distribution of identical objects is in fact slightly more important than distribution of distinct objects, but we will see that. So if you have n identical objects, we will see that when we go to the questions on this chapter. You'll realize the depth and differential of questions in terms of how many questions can be framed on distribution of identical objects, and the limitation of the question on distribution of distinct objects. So it makes interesting understanding and interesting quants when you're talking about distributing from distribution of identical objects. So if you have n identical objects and you have to distribute it, you distribute them amongst R people or groups. You want to distribute them amongst R people or groups. Then in such a scenario, if you want to count the number of distributions you can have, and in this scenario we are allowing 0. You can give 0 also to any person or any group. In such a scenario, the number of distributions is given by the formula n plus r minus 1 cr minus 1. And this situation can be understood where, suppose you have 4 identical objects which you need to give between two friends x and y. Let's say 4 identical chocolates which you want to give between x and y, 2 people. So, and if you want to count the number of distributions in this scenario, you can have one distribution as 4, 0, a second distribution as 3, 1, a third as 2, 2, a fourth as 1, 3, and the fifth as 0, 4. So you can see that the number of distributions is 5. And if you take n equals 4 and r equals 2, because you are distributing 4 objects amongst 2 people or 2 groups, and you use this formula, you will get the answer 4 plus 2 minus 1 C2 minus 1, which is 5C1. So this is the distribution formula. So if you have distributing 20 identical chocolates amongst 5 people, n20 r5, and the answer will become 24C4 when you are counting the number of distributions. So this is an interesting question, and it gets even more interesting if you talk about the next aspect of this, and that is if 0 is not allowed. How do you handle that? But before that, let's say this question can come in a variety of avatars, and one of them could be that if I tell you that x plus y plus z is equal to 20 and x, y, z are whole numbers, then how many solutions does x plus y plus z equals 20 have? The condition is x, y, z are whole numbers. So this scenario can be seen as if you are distributing 20 objects which are all identical amongst 3 people, x, y, z. So in this scenario, n is taken as 20, r is taken as 3, and the answer becomes 22C2 using the n plus r minus 1 c r minus 1 formula. N is 20, r is 3 gives you that answer. So this is a scenario in which this formula applies. But I just need to change this question to x, y, z are natural numbers, and this formula will not work directly, because in that case 0 is not allowed. Or for that matter, if I tell you that distribute 20 chocolates, 20 identical chocolates amongst A, B, C, such that each person gets at least one chocolate. So in this scenario, what you have to do here, essentially, you can't use the formula n plus r minus 1 cr minus 1 directly here, because it is also counting distributions like 20 0 0 or 19 1 0, and these are not allowed in this with this constraint. So there is a very simple bypass to this. The bypass is, and you don't need to change the formula at all, you continue using the same formula, and the bypass is that from the 20 objects, first you give 1 to each of ABC, because that's the constraint. Everybody gets at least 1, and this constraint can also be phrased that 0 is not allowed. So first what you do is you give 1 to each of the 3 people, and then you are left with, when you give 1 to each of these 3 people, you are left with 17 objects which are all identical, and you are now allowed to give those 17 objects freely to these 3 people as you want, including 0 distributions. So in this case, what will happen is n is 17, r is 3, and the formula will become n plus r minus 1 cr minus 1, so that will become 19C2, and that will be the answer. So you can fill this box in 19C2 ways, and every time you fill this box, there's with these 17 objects, there's an actual distribution of the 20 objects which is happening if you superimpose these two distributions into one distribution. So for example, suppose I decided to give 15 1 1, and this will be one of the 19C2 solutions for distributing 17 objects. So in this scenario, how much did A get out of 17? The answer is 15. But if I ask you how much did A get out of 20, then A has got 15 and 1 16. So this 15 1 1 solution here is actually the 16 2 2 solution. So what will happen is that this is like a proxy count. This will count your total distributions, and at the same time not allow A or B or C to get 0. So instead of 15 1 1, if you had distributed 16 or let's say you are given 17 0 and 0 to all the 3 people, if you had distributed 17 0 0 to the 3 people, then A would have got 18, B would have got 1, and C would have got 1 again. So 19C2 solves this problem, and the advantage of this is then I can give you other questions also. So if I say A plus B plus C is equal to 20, and A, B, C are all greater than equal to 2, and they are integers greater than equal to 2, then how many solutions does this have? So the resolution of this would be that this is like distributing 20 chocolates amongst A, B, C with minimum 2 to everyone, is the same question. So what you do is you give 2 to A, B, C each, you're left with 14 chocolates, and those 14 chocolates you can distribute amongst 3 people. So n is 14, r is 3, and the answer becomes 16C2 using the n plus r minus 1 cr minus 1 formula. So I call this approach as the modified n approach. You'll not find that word in maths books, but I call this the modified n approach to understand logically what I'm doing. So what I do is when 0 is not allowed, I can't use the original n. So distribute 20 different chocolates amongst A, B, C such that A gets minimum 3 and B gets minimum 5. So and there is no constraint on C. So all I have to do is meet this constraint, give 3 to A, 5 to B. N modifies from 20 to 12 now because I have given out 8 objects. So N12, R3, N plus R minus 1, C R minus 1. The outcome is going to be 14C2. So this is how you handle these distribution questions when you are talking about distribution of identical objects. Now, when you talk about distribution of distinct objects, then you use the formula which is defined as the MNP formula. Now, this MNP, M into N into P formula is also a formula which will be used for arrangements. So I'll show you when I'm doing the next lesson in this chapter, which is on arrangements. So I will show you the use, the small use of the 2-3 questions on which you use the MNP formula, MNP for distribution of distinct objects. So I say MNP formula has its main usage in the arrangement scenario. But while doing MNP, we'll also look at the use of the MNP. The same formula gets used for distinct objects distribution. So we'll see that in the next lesson. And please do the attached assignment to this lesson. And I hope you're enjoying this course. And I'll see you on the other side. Bye-bye.